JavaScript, callback functions are like the lifeline of asynchronous programming. A callback is a function that's passed as an argument to another function, which then executes some code and calls the callback when it's done. It's like dropping your car off at a mechanic. You leave it with them, they fix it, and then they call you back when it's ready. Callback functions are essential for handling tasks that take time, like fetching data from an API and so on. Let's check out an example to see how this works. Here we have two functions, greet and farewell. If we run this code, we see the functions are logged in the order they were called. Hello followed by goodbye. But what if we make the greet function asynchronous by adding a set timeout? If you're not familiar with set timeout, it adds a delay to the code inside of it. Running this code now, we see goodbye is logged first and hello comes shortly after, thanks to the set timeout function. This shows how asynchronous operations can change the order in which code executes. If we wanted to guarantee goodbye came after hello, we could use a callback function. To use it, we simply pass an argument to the greet function. We'll name it callback, and inside, we call the callback function after hello is logged. When we call the outside function, we pass the name of the callback function as a parameter. In this case, we pass the farewell function to the greet function. It's important to note that we do not include the parentheses in the parameter, as this would immediately call the function. Now if we run this, we see they log in order. Let's look at another example that shows how to better use a callback in an asynchronous task. Here, we can define an async function, getPokemon, that will take two parameters, a Pokemon ID and a callback. We can get the Pokemon data from the Poke API using fetch, then pass the data into some callback function when it's retrieved. Our callback function, logPokemon, will simply log the Pokemon's name to the console. If we call this function using ID1 and passing our callback, we see it logs Bulbasaur. But callbacks aren't just limited to logging data. They can be used to manipulate DOM elements, process data, handle user inputs, and more. For example, imagine you have a form where users enter their information, and you want to validate this data before sending it to a server. You can use a callback function to handle the validation process. In this scenario, the validate data function checks if the data is valid and then calls the callback with an error message or a success message. The handle validation function processes these messages, logging them accordingly. For instance, if the data is valid, it logs data is valid. If we change the username to null, we see it logs invalid data. Instead of logging these messages to the console, we can update a DOM element with the class validation message to display the messages directly on the web page. This way, any changes in the validation results will be reflected immediately on the page, providing a better user experience. Callbacks are incredibly versatile and powerful, allowing you to handle complex asynchronous operations with ease. They can help make your code more modular, readable, and maintainable by separating concerns and promoting code reuse. And that's a wrap on callback functions. If you found this video helpful, don't forget to like and subscribe for more content. Thanks for tuning in, and until next time, happy coding.